Welcome to Module 17. In this module, we'll help you understand session hijacking, which is a type of attack that consists of an interception of a session. Session hijacking attacks allow an attacker to gain unauthorized access to services by taking over the active session of an authorized user. How can this be carried out? As you know, HTTP protocol is stateless. To maintain user state, cookies have to be introduced. Cookies are stored in web browsers and often contain unique user identifiers which are processed server-side to set up sessions containing user information. While an ID is assigned to a specific user, the exploitation of the XSS vulnerabilities we've mentioned in previous modules could allow an attacker to steal a cookie with user session ID to access services. The same could be achieved by using scripts which monitor user actions. Let's see how this works in practice. Take a look at this very simple script. If you visit the admin login PHP URL, the admin variable is set for the current session, which means that the user will have administrator rights. The test PHP file is also available. The file utilizes the PHP session mechanism, and if the admin variable is set, the message hacked will be displayed. The vulnerabilities have been successfully exploited. If this is not set, the message not hacked will be displayed. Imagine that a normal user is being authorized in a service. During this process, a unique session ID cookie is generated and session information is saved server-side. Let's use the live HTTP headers add-on to see communications between the user and server. As you can see, once the login PHP address is entered, a PHP SesID cookie is sent to the server. The cookie is used by default to store PHP session IDs. If the administrator falls prey to an XSS attack or data transmission has been intercepted, an attacker can obtain the content of the cookie. Let's open a private tab which uses a new set of cookies, rendering the previous session inactive. Visiting the test PHP URL doesn't give us access to the control panel this time. Let's use the live HTTP headers add-on again. As you can see, a different PHP session ID is sent to the server. The add-on's replay function allows you to freely modify the sent request. We'll set the admin session ID using the cookie we've previously acquired. Next, we send the request to the server using the replay function. As you can see, the access has been granted. How can we protect ourselves against these attacks? The first prevention method is securing the application against XSS vulnerabilities, as these types of flaws might be used to leak session ID cookies used in our service. Using the encrypted HTTPS protocol will guarantee that intercepting cookies won't be feasible outside of the user's computers. You can also add the HTTP-only parameter to cookies, which should disable JavaScript access to cookies. A frequent regeneration of session IDs is also a good idea, especially after a successful login. Another prevention method is checking the IP address related to the session. The address should not be changing while the session is in progress. If it is, this could point to a potential session hijacking event. Many ready-made scripts implement their own session mechanism which checks the IP address used in a session. That's all in Module 17. Thanks for your attention and see you in the next module, which will talk about session fixation attacks.